Hey everyone, today we'll be going over LeetCode problem number 5, longest palindromic substring. This is another problem off the Blind 75 list, which is a list of problems commonly asked during technical interviews. In this problem, we are given a string S, and what we want to do is simply return the longest palindromic substring in S. Now, a palindrome is a string which reads the same both frontways and backwards. For example, we have the string ABA over here, and we see that if we were to read this string frontways, we have first an A, then a B, and then an A. Instead, if we were to read this string backwards, we have again an A, then a B, and then an A. So we see that reading it frontwards and backwards, it is the same, and so this string can be called a palindrome. Now, there are different ways to approach this problem, and first we'll go over the brute force approach. Now, the brute force would be to take into consideration every possible substring in the string S. And in order to do that, what we could do is start with each and every character in the string and see every possible substring we can form beginning with each character. So for example, we would start with the B and go and find every substring in S that starts with the B. So we know that the B itself is a substring, but then we could also have BA as a possible substring, BAB, BABA, and BABAD. Then we would move along to the next character in our string, and we would go and find every possible substring starting with A. So we have the A itself as a substring, but then we would also have AB, ABA, and ABAD. So then we can understand that using this approach, it would take an O of n squared time complexity to go and find every possible substring in our string S. However, our algorithm is not done there, because on top of that, we also have to determine whether or not that specific substring is, in fact, a palindrome. Now, in order to determine whether a string is palindrome, what we would do is then go and read the string frontways and backwards and do a linear scan in order to determine whether or not the string is a palindrome. So we would start with an A at the front. We would have, say, like 2 pointers and put a pointer at the A and a pointer at the second A at the back. So we have a left and right pointer. We would determine whether or not these two characters are the same and continue going to the center to make sure that the next characters are also the same from both sides. So we would start from the sides and go towards the center. It would take an n squared time complexity to find every possible substring in our string S, and another linear time complexity to determine whether the substring is a palindrome. So overall, this would make our time complexity n cubed. So our brute force approach would have an n cubed time complexity. Now, how can we optimize this approach? Well, one way would be to change the method that we are using to determine whether or not the string is a palindrome. In fact, instead of starting out from the sides, what we could do is have our 2 pointers left and right start at the center, and instead expand towards the sides, and determine that each time our current character that we are looking at is in fact the same. So for example, we would start our left and right pointer both at the B. We know that B is equal to B, and then we would move our pointers towards the sides to determine that the expanded substring is also a palindrome. We would have our left pointer then at the A and our right pointer at the second A. We see that these are also equal, so we know that the string ABA is a palindrome. Now, using this approach, we could optimize our time complexity from an O of n cubed time complexity to an O of n squared time complexity. So we have here again the same string, BA, BAD, and we said that this time we want to optimize our approach by evaluating whether each substring is a palindrome by starting from the center and expanding to the sides. So what we could do this time is, instead of finding every possible substring and then determining whether or not it is a palindrome, instead what we would do is start from every character in the string and take into consideration the longest possible palindrome, which has as the center that specific character. So we would start, for example, with the B. Now we would go and see what is the longest possible palindrome which has B as its center. So we know that the B itself is a palindrome of length 1, But when we go and expand to the side, we know that to the left side, we have no character, while to the right side, we have an A. So of course, for this specific character B, the longest palindrome having it as a center is the string B of length 1. Now we would continue on to consider the longest possible palindrome having A as the center. We would see A itself is a palindromic substring of length 1, and when expanding, we would see that at the left and right side, we have both B's. So the longest possible palindromic substring for A as a center would be the substring BAB of length 3. And we would do the same for each and every possible character in the string, finding the longest possible palindrome having that character as the center. Now for this specific problem, we would see that we can have two possible outputs. In fact, we can have ABA as a possible output, but we could also have BAB as a possible output. However, we are told in the LeetCode problem that when we have a tie, we can return any possible substring and it will be evaluated as correct. Now, as we can see, for this specific case, what we are doing is taking every possible character in our string, and then for each character expanding to the sides to figure out what is the longest possible palindrome. So we know that it would take an n time complexity, linear time complexity, to go and take every character in our string, and then it would take an additional n or linear time complexity to expand to the sides of the entire string. So this would make our optimal approach an O of n squared time complexity. Now the only thing left we have to consider is the possibility that our palindrome can actually be a palindrome of even length, not odd length. And this is just an edge case that we can fix easily in our code, where instead of taking into consideration one singular character as the center of our palindrome we will expand from, we will take into consideration two characters and expand from there. We're going to start off our code by initializing our max length variable to 0, as we have not started our search yet. And we're also going to have a max substring array, which will store the positions of the left pointer and the right pointer for our max substring. So initially, these pointers will be put to 0. However, when we find the left pointer and right pointer of the max substrings, then we will go and replace that in this array. And then we're going to have our for loop in order to take into consideration every possible character as the center of the substrings we are looking at. Now we know we have two cases. We have a case where the substrings will have an odd length, and a case where the substrings will have an even length. We'll start off with the case where the substring has an odd length. Now we know that what we want is to, in the odd case, have one singular character as the center of our substrings. So we can make our left pointer equal to I, and also our right pointer equal to I. And then while this left pointer remains in bounds, and so does the right pointer remain in bounds of the string, what we will do is check to see that the left pointer and the right pointer point to the same character. And if this is true, all these checks are true, we want to continue expanding the substring that we are looking at. So we can make our current length equal to the right pointer minus our left pointer incremented by 1. And if this current length beats our max length, then what we want to do is update the information we have for our max substring. So we're going to update max substring to now hold the indices for the max substring and have the left pointer at index 0 and the right pointer at index 1. And of course, we also have to update our max length for future checks. So our max length is going to be equal to current length. Now, at the end of each iteration, what we want to do is simply continue expanding our substring. So from the left, we will decrement 1 point, and from the right, we will increment 1 point. For the case of an even length substring, what we want is to take consideration as the center 2 characters, not just 1. So we're going to make our left pointer equal to I, but our right pointer equal to the character coming after I. And once again, we're going to have the checks to make sure that the pointers are still in bound. So left needs to be greater than or equal to 0, and right needs to be smaller than the length of s. And also check that these pointers are pointing to a character which is equivalent. And what we want to do is, of course, calculate our current length as right minus left plus 1. And if this current length, once again, beats our max length, we want to update our solution. So again, we're going to update max substring so that it has our current left and right pointers. And we're going to update max length for future checks. And once again, at the end of each iteration of our while loop, what we want to do is continue expanding our substring. So we're going to decrement our left pointer by 1 and increment our right pointer by 1. And having finished with our while loops and our for loop, we have now determined what our maximum palindromic substring is. So we can go and destructure our max substring variable array in order to get the final left pointers and right pointer. And afterwards, we can return that longest palindromic substring as a splice from our substring. So it's going to be S going from the left index to the right index, but we're going to put a +1 here because we know that the ending index is non-inclusive. So let's make sure this runs and submits. And we see that it works. Thank you so much for watching this video. If you enjoyed it, please like it and subscribe to my channel. I'll see you on the next one.